So in this video we're going to calculate the Taylor polynomial for 5 terms at the point 1 for the function natural log of x. And when you're calculating a Taylor polynomial, always good to remember what you're trying to calculate. So we're trying to calculate for 5 terms, which is in the question there, and the point is which you're trying to calculate it for, which is 1, and our function is natural log of x. So the formula for a Taylor series, which is here, got it on the bottom here, that's the generic formula. So basically the degree is n, so all the n's will become 5 in our question here, and at point A, so all the a's will become 1s. So we've got t5 of x essentially equals f of 1, so the value at 1 for our function, so that'll be natural log of 1. And then we've got these calculations here. So the first derivative of a, so at a, which is 1, so the first derivative calculated at point 1, divided by 1 factorial times x minus a, so a in this case is 1, so x minus 1, and then to the power of 1. The next term we're going to calculate is the second derivative at 1, so a is 1, again all the a's are 1, this time divided by 2 factorial, and then x minus 1 again, squared. And then the third derivative is calculated at 1, this time divided by 3 factorial, x minus a, which is x minus 1, cubed. And now you can see there's a pattern forming here now. So here we had third derivative 3 factorial cubed. Now we've got the fourth derivative 4 factorial to the power of 4. And after that we've got the fifth derivative 5 factorial to the power of 5. And that's the case all the way along. So what do we do next? So the first thing we're going to do is differentiate natural log of x 5 times. So each time we calculate the natural log of x, we're going to calculate the value of each derivative for 1. So here we go. So let's have a look what we've got here. So the first 2 bits we've got here is the function written down, which is natural log of x, and natural log of 1 is 0, because we're interested in calculating Taylor polynomial at point 1. So natural log of 1 is 0. And then you take the derivative of natural log of x to get the first derivative. And whenever you're differentiating a natural log of something, you take the reciprocal of what's inside those brackets. In our case it's x, which is then 1 over x, and then multiply it by what's inside. As in the derivative of what's inside. So the derivative of x is just 1. So in our case here, it's not going to make any difference because multiply something by 1, it just stays the same. 1 over x can also be written as x to the power of minus 1. So when using the power rule, that's sometimes easier to work with. But I'm going to show you another way, a nice little shortcut, so you don't have to worry about that. You can still leave it in fraction form. And then for x equals 1, 1 over 1 is just 1. So the first derivative is calculated at 1. Okay, so moving on. So now we go to the second derivative. So to find that, we just take the derivative of this first one, and then using the power rule, so x to the power of minus 1, this minus 1 comes to the front to multiply it, and then this power sign here will decrease by 1. So we end up with this one here, so minus 1, which ends up here, and then that becomes minus 2. So minus 1 times x to the minus 2, which could also be written as minus 1 over x squared. And then calculated for 1, minus 1 over 1 squared is just minus 1. So the derivative there is minus 1. So the third derivative, we take the derivative of this second derivative here. And what you could do is imagine that this 2 here is a minus 2. So minus 1 times minus 2 is 2. And then put the 2 on the top. And then increase the power this time. Then you get 2 over x cubed. Or following the other way, minus 2 times minus 1, which is the same as what we did here, which gives you the 2, and then decrease the power by 1. So when you're writing it like this. So again, calculated at 1, 2 divided by 1 cubed, which is what 1 cubed is always 1. So the third derivative at 1 is value of 2. And again, take the derivative of this function here to get the fourth derivative. So 2 times minus 3 is minus 6. increase the power, x to the 4. Or again, 2 times minus 3 is minus 6, x to the minus 4. And then the value of 1, so 1 to the power of 4 is 1, so minus 6. So the fourth derivative is minus 6. And again, taking the derivative here, minus 6 times minus 4 is 24. 24 at the top. Then a 4 increase the power by 1 becomes x to the 5. So then we end up with 24 divided by x to the power of 5. Or using the other way, you've got minus 4 times minus 6, which is 24. 24 goes to the front, and then decrease the power minus 4 to minus 5. And then 24 over 1 to the power of 5 is just 24 over 1, which is 24. So now we can start to put some values into our Taylor polynomial, and I'd advise you not to do it too fast and all in one go because it can get a bit confusing. So we can substitute the 5 in there for the n, so that's the 5-degree Taylor polynomial, that's what that means here. The value at 1, then the first derivative at 1 over 1 factorial, so the a's have gone in here now, you see. Then x minus a, which is x minus 1. Then the second derivative at 1, this time 2 factorial, x minus 1 squared. Third derivative at 1, 3 factorial, x minus 1 cubed, and so on, to power of 4, and to power of 5, and so on. So now what we can do is we can substitute the values for all the derivatives that we've just worked out, and put them in the top of the fractions, and see where we end up with. So here we go, this is what it looks like now when we tidy up a little bit. So the 5-degree Taylor polynomial at point 1 for natural log of x. We now get to the stage now where we know that the value at 1 was 0. So I'll just show you that again. So we calculated that here, that was 0. So f of 1 is 0, so that's why that goes in there. The first derivative was 1, so let's go back to that. So that's where we calculated that, so that's 1. So then we put the 1 on the numerator. 1 divided by 1 is just 1, so 1 divided by 1, and x minus 1, so that's in there nicely. Second derivative, we calculated as minus 1, so then we put a minus 1, so where that 1 was there, now put there as a minus 1, x minus 1 squared. Third derivative was 2, so 2 over 3 factorial, which is here, and x minus 3 to the cubed. Fourth derivative is here with minus 6, so we put a minus 6 in here, and then end up here minus 6 divided by 4 factorial, x minus 1 to the power of 4, and then add the fifth derivative of 1, which is 24, 24 divided by 5 factorial, x minus 1 to the power of 5. And then next stage what we can do is we can start calculating all these factorial values, which we know 2 factorial is 2, that's 1 times 2. 3 factorial is 6, 1 times 2 times 3. 4 factorial is 24, which is 1 times 2 times 3 times 4. 5 factorial is 1 times 2 times 3 times 4 times 5, which is 120. And then we can start to simplify our fractions off a little bit more. So therefore we end up, once we clean this bit up here, we end up with minus 1 plus x. Now where we end up with that is, we've got x 1 over 1, which is just 1, so 1 times x times 1 times minus 1, so 0 plus x minus 1. So 0 plus x minus 1 is basically minus 1 plus x, or you could even put x minus 1, but it's more commonplace to put the value of any integers at the front there. So therefore that's where we get to the minus 1 plus x first. Now this one here is a bit more easy to understand what's going on. So basically that's minus 1 over 2 factorial, which is minus a half. So this plus sign can become a minus, and then put the x minus 1 squared on the top. So then we end up with x minus 1 squared over 2. You could also put a half there if you wanted, but I think this is a bit neater and less writing, so I think it always looks better. 2 divided by 3 factorial, that's 2 divided by 6 is a third. So we can put 3 in the denominator there, and then x minus 3 cubed goes on the top, and that stays as a plus sign. Next one, the fourth one, we've got plus and a minus 6. 4 factorial is 24. Minus 6 divided by 24 is minus a quarter. So here's we have, you could put again, you could put a minus 1 there and divide it by 4, but it's just neater again, x minus 1 to the 4 and a 4. Don't forget to flip the plus sign to a minus sign. Then the fifth one, 24 divided by 5 factorial. Well, 5 factorial knew was 120. 24 divided by 120 is a fifth. So again, 5 in the denominator, and x minus 1 to the 5 bring to the top. And that there is your answer. And now I've drawn a graph, and just to see how close we are at the point 1. So here it is. So this dotted line is the graph for natural log of x, and this thick black line is our Taylor polynomial. And we wanted to calculate at 1. So at 1, that's where we are interested, where x equals 1, and you can see it's very accurate. As it approaches 0, then it starts to move away a little bit. And again, as it approaches 2, things start to go a little bit different as well. But 1 is all we're interested in, and you can see it's really accurate. So we can be satisfied with our answer. And there we go, and that's our answer. So minus 1 plus x minus x minus 1 squared over 2 plus x minus 1 cubed over 3 minus x minus 1 to the 4 over 4 plus x minus 1 to the 5 over 5. Okay, and that completes the question. And thanks for watching. Any comments, please leave below.